their software and the Apple. So these are the questions we've already been through. So I'm just recording them so you can go through the answers that we discussed in class. So I'll just leave them there. You can then freeze the screen when you want to check any answers. I'll leave it for a few seconds on each page. So these are the ones we've already been through. See if the lighting helps. So this is the second question we went through on the uses and dangers of electromagnetic waves. The third question we went through was on the LDR circuit with the graph and how you only need to use two significant figures. Yeah, the values are not known any more accurately than two significant figures, which is why we said you can just quote it to two significant figures, and knowing which equation to use to work out the voltage, having given you the current and the resistance. We then looked at why covering the LDR with dark sheet of paper increases its resistance and thereby reduces the current in the series circuit, so which means that the lamp also will be less bright because it will have less current going through it. So I think we've been through all these. We were then looking at question 4, which was upthrust, balancing the weight, Newton's first law, being the resultant force being 0 because the ice cube is at rest, an extra force then being added. You can see how the height difference between the bottom of the ice cube and the surface of water is what gives you the pressure difference that they're talking about. So you need to know the equation for pressure difference as being the depth or the height in the ice cube is under. So that basically the bottom of the ice cube is at a higher pressure than the surface of the water, and this equation tells you how much the pressure difference is. And then in the next part of the question, they want you to use the data they've given you to calculate to see that the 0.041 height difference, the 1,000 kilograms per meter cubed, and the 10 multiplied together, you get about 410. They want you to show that it's about 400 pascals. We did that. They then want you to show them that you know the equation for pressure is force over area. They then give you the area of the ice cube at the bottom. So that's, once you know that, you can work out the force at around this 400 pascals. So you could either use the 400 or the 410 multiplied by the area given, and you get either a 0.68 Newton force or a 0.697 Newton force, depending on whether you use the accurate value or whatever. If you remove the object, the force that's pushing the ice cube down, there will be an upward force, a resultant upward force, because the upthrust momentarily will be greater than the weight. So you need to say there is a resultant force, and this upward force, which is upthrust, is greater than the weight. And that's how you finish off this question. Okay? We talked about the question 5. Question 5, how 40 kilohertz, what does it mean? 40 kilo means 40,000. And it's ultrasound, so it's waves. Oscillations is another word you could use, or vibrations per second. Hertz means per second. They want to know if you understand the terminology. Okay, so that's question 5, the start of it. Part B is about V equals F lambda, the wave equation. They've given you the velocity at the top of the page, and they want you to work out the wavelength using the frequency that they gave you in the first page, which is 40,000. So if you divide the velocity by the frequency given, 345 from up here, divided by 40,000, you will be able to work out the wavelength is in a fraction of a meter, so it's 8.6, standard form 10 to the minus 3 meters. You can write it out in long form by moving the decimal place back 3 places, so it'll be 0.0086 meters, okay? And then it asks you to look at the next bit about the echolocation we talked about. So they're sending out the sound. The distance to the wall is 2.35 meters. So it travels the calculated time between the sound wave being emitted and received by the device. So it goes to the wall and back. So it goes 2 lots of 2.35. They want you to realize that this is a common question in GCSE, that it goes there and comes back. So the total distance traveled is 4.7. If you divide the distance by the velocity, you can work out the time it takes. So that gives you a 0.136 second answer. And then they say, why the device emits visible light as well? That's basically to show visually the position that the distance is being measured to or from, in this case, the wall. So we're going to the wall and then back from the wall. So it's making sure that you're pointing it where you think you're pointing it. Okay, so that is question 5. Part D then goes on to ask you, sound waves and light waves have different frequencies and wavelengths, but they want you to describe 3 other differences between sound waves and light waves. Now we went through these. These are any 3 from this list, as long as you do it for both sides of it. So for example, you must say sound is longitudinal while light is transverse. To explain a difference, you've got to put both sides of the difference in your communication. So I'll just leave this up there. You can stop the video and pause it to see how you need to improve your own answer. Okay? So that's as far as we got. The continuation of that then is question 6. I'm just going to pause the video. Hopefully I'll be able to do that. I'm not sure I can. Let's see.